So 12.2 is about congruent polygons, and what we're trying to answer is the following question. Given two congruent triangles, how can you use rigid motions to map one triangle onto the other triangle? So we know a lot of things about that question up there already. We know what congruent means. We know that we can show figures of congruent through rigid motions. In other words, a movement of a figure, but not changing its shape. And the way we're going to be able to answer this question is to figure out how do you identify and use corresponding parts. This is the big idea right here today. This is the big idea. How do you use corresponding parts? So you might want to underline that right there. Big time important today. And then we're going to call what's a third. We're going to use what's called a third angle theorem in a triangle. Third angle theorem in a triangle. Basically, third angle states this. If the first two angles of triangles are equal, then the third ones must be equal. Okay? And we'll talk about that in a bit. So let's do this first, guys. Let's first of all talk about what are corresponding parts to congruent figures. Specifically in this example right here, corresponding parts are angles and sides that are what? The same measure in congruent polygons. All right? Let's do this. I'm going to label my triangles over here in my vocab. Call this triangle up here ABC. And call this triangle, oh, I don't know, how about UHS? How's that sound? Union High School, John.
Oh, okay.
Good with that? Okay, what's ABC mean? John, that was good. I gotta give you that.
What is that?
Already been chewed up. It's like ABC gum when you were in elementary.
Oh.
You want some ABC gum? What's that mean? Already been chewed gum? John, I love your sense of humor, bud.
Thanks.
All right. Hey, I'm going to go ahead and do this right here. I'm going to go ahead and put some tick marks and stuff in here. So let's do this. On this shorter side from A to C, put one tick mark here. And from U to H, put a tick mark there. All right. And then from B to C, put in two tick marks here. And two tick marks over here for H to S. And then we'll put three tick marks in A to C. And three tick marks right here. Right? Those tick marks identify equal measures, okay? And what we're trying to show is what corresponds here. What corresponds by sides. So just check this out, guys. Corresponding parts in this right here. If I said this, what does AC correspond to, guys?
Or AC.
AC is a one tick mark, so what's that going to correspond to? UH, right? How about my side CB? What would that correspond to? HS, yep. And then how about the side BA? What would that correspond to? US, right? Okay. Good there? All right, now I know I haven't put the marks in for the angles, but just looking at those triangles, which angles match up? Let's just start angle A. What do you think angle A matches up with? How would you make a rigid motion for triangle ABC to get it to fall on UHS? And if you did make a motion right here, where would A fall on this triangle to get that to fall completely on it? Where would angle A fall? Angle U. So angle A corresponds to angle U. How about B? Where would B fall? B would fall on S, right? Angle B to angle S. Not saying that that's what this stuff is, but some of you might take that out of context a bit. So don't do that. What's my last corresponding pair of angles? C to H. All right, so guys, anytime you're talking about any congruent figure, there's always corresponding parts. There's parts that match up. In other words, you're saying, how do you take the one figure, map it onto the other, and then what lines up? Which angles match up? Which sides match up? So you're going to hear me say corresponding parts often. When I say corresponding parts, you just need to know it's the stuff that matches up. Make sense, everybody? Okay. Hey, I need some help on this down here for the first example then. We'll get through this first example. Identifying corresponding parts. It says write a congruent statement for the triangles. Identify all pairs of congruent corresponding parts. Okay, help me out here, guys. How is this triangle labeled for you guys in your notes? I know it's labeled for you already. What's this vertice down here? A.
B.
And then how about this angle?
X. Y. Z.
Okay, help me with the number of tick marks in the side. How many in this side down here? One.
No, that one has 3.
3. How about here?
2.
And there's 1 here. So that means there's 3 here. There's 1 here. There's 2 here. I believe I put some arcs in the angles as well. Which angle in ABC has just the 1 arc?
A.
Which one has the 2 arcs? So C has 3, so I'm guessing X has 3 also.
Yeah.
Okay, so that's what you have in your notes right here. So our job, first of all, is identify a congruent triangle. So guys, I'm just going to start this out. Yeah. Yep. I'm going to start this out first of all. Identifying the congruent parts. I'm going to say a triangle ABC is congruent to another triangle. Okay, now guys, notice the order in which I wrote that first triangle, A to B to C. Okay, the order with which you write that first polygon, or how you name that first polygon, is going to determine how you name that second polygon. So if I asked the question and said, well, take a look at this top one right here, guys. Angle A has how many arc marks to it, guys? How many arcs to angle A? Okay, A has 1. Now, that's going to match an angle down here that has just 1 arc, which is what? Y. So since I listed A first, what must you list first for that second figure that you're trying to show congruence to? Y. Okay. Up there in that first triangle, a side B, or angle B, I'm sorry, was listed second. Vertex B is listed second. So as B is listed second in that first one, what has to be listed second in the other triangle? Z, because of the arc marks. I say arc marks and I think aardvarks, but that's okay.
I thought that too.
All right, and then finally, what has to go in after Z? X. So it really doesn't matter how you write the order of that first polygon. Okay, but that first order is going to dictate how the order goes for the second one, isn't it? Make sense to you? Okay. So this would be your congruent statement right up here. We know that these two triangles are congruent. Now, what they ask you to do is to show corresponding parts. So let's put the corresponding parts down here. Let's put the corresponding sides on the left, and let's put the corresponding angles on the right. So you guys help me with sides. I'll start the first one. Let's do side A to B. What does A to B have to correspond to, guys? What's AB going to correspond to in the other triangle? Y to Z. Notice this right here, guys. How is AB listed up here in order? First and what? Second. How is YZ listed up here in order? Same order, isn't it? Would I really even need the drawing to be able to do this at all? I wouldn't, okay? But the drawing is handy. Let's pick the second side in this triangle, B to C. What's BC correspond to, kids? ZY, or ZX, that's it, ZX. So BC, second, third, ZX, second, third. Good. And then my last side right here is C back to what? CA is going to correspond with XY. Okay. All right, help me with the angles quickly. What's angle A correspond to? Do I need the drawing here at all, or can I look at this? Can I look at the orders? A is listed first as Y is listed first. So angle A corresponds to angle Y. Let's just not even look at the triangle. What's angle B have to correspond to according to the orders up here? Z. You are very BZ today. All right. And check it out. How many arc marks to B? How many arc marks to Z? So does it work just by going by order or by diagram? Works pretty well, doesn't it? Okay. And then finally, what's angle C match up with? C matches angle X. All right. So I think you're pretty okay with identifying congruent figures, congruent polygons, and then taking congruent polygons and identifying corresponding parts of that. Pretty easy, isn't it? Pretty easy. Okay. All right, so let's rock ahead to the second page. I think we'll get this next example done, and we'll probably try and stop there. So let's get example 2 done. And then I'm not going to give you an assignment today since we're on a short day. But make sure you bring your notes tomorrow so we pick this up first thing in the morning, okay? Everybody have what they need on the first page there? Any questions so far? All right, pretty straightforward. Okay, next page here. I need some help here, guys. Just give me the vertices first. I kind of screwed it up big time on your notes, but let's do the first one. Is this D up in the top left?
Yeah.
So it goes in order D, E, F, G. Like so?
Yeah.
Okay, now help me out here. Where is Q? Is Q down on the bottom right?
Yeah.
And is M right here?
Yep. And
Okay. Let's do sides. There were some side labels up there. Was there a distance from D to E at all? 8. 8? Was there a distance E to F? No. F to G?
12.
Anything D to G? Okay, help me with the sides up here. N to P. That length N to P given?
No.
How about P to Q?
No.
Q to M?
X minus 2.
And how about N to M? Okay, angles. Help me with angles. Angle D. 102 degrees. Angle G.
84 degrees.
Angle F.
68 degrees.
And there wasn't an angle E, was there? Okay, angle N.
Nothing.
P.
3x plus 2y. And that's it.
And is that it? Okay. So guys, the first thing it says to do is solve for x. Find the value of x, right? Well guys, do you agree that x is right here on this side MQ? Everybody agree with that? Okay. Well, what they're saying up here says in the diagram, DEFG, the quadrilateral DEFG on the left is congruent to quadrilateral QMNP over here. All right, now guys, look at this right here. We need to find the distance from M to Q, which is where the X is, right? Okay. Well, guys, M to Q right here, isn't M and Q the first and second one listed up there in that order? Okay, so in the other order up here, what would Q and M have to line up with or correspond to, in other words? D and E. Okay. Well, guys, what is the distance from DE? 8. So this means that X minus 2 has to equal what value? 8. These sides correspond to each other. This side, basically, you would rotate it onto this. And when you rotate it on, X minus 2 is going to fall on the 8. So to solve this right here, you're simply going to take the X minus 2 and set it equal to what, guys? 8. What's that make your X value, kids? X is equal to 10. Okay, very good. Now, the other part says to solve for Y in this diagram. Well, guys, Y is in an angle measure, isn't it? Angle what? Where the Y is? P. What does P correspond to in the other figure? G. And you can go by orders. P is listed last up here. G is listed last. Do you know the angle for G?
84.
So what we're going to do is we're going to take this expression for angle P, 3x, oh boy, plus 2y, and set that equal to what? 84. Yikes, there's a problem here. There's an x and a y in here. How do I proceed?
Change the x to 10.
You already know that x is what value? 10. So 3x is really going to become what value, guys? 30, you bet. So this is now 30 plus 2y, and we're going to set that equal to 84 What am I subtracting first, kiddos? Subtract 30. Subtract 30. And we get 2y is equal to 54. All right, my little math minions, tell me what 54 divided by 2 is. 27. Perfect. Right? If you can just understand what corresponding parts are, whether it's by the order in which stuff is listed or by how the diagram is shown, you're basically just setting stuff equal to each other today. All right? So we'll pick up the rest of this tomorrow. You know, it gets a little more intense with this right here, but I think that'd be a good place to stop right there. What questions have you guys got so far? Okay. Don't forget the stuff that's due for today, 4 o'clock, meet that deadline. Make sure you meet that deadline. I do realize it's an early out, so if you need to turn in at the end of the day, if the end of the day for you is noon or whatever, still get it to me, okay? Thank you.